Right. So I brought a few things out of my pockets. It's always a killer. I brought a few various and sundry bifaces along casts rather, mostly, to give you a sense of the fact that things are quite different, or can be quite different. Here's three different. Let's use that one. Three different biface technologies involved here, and these are fairly extreme differences. And this is yet another one here. Those are casts. This is a piece of flint. That's the junk I have to work with in it and extricate. Yeah. That and this. And this stuff comes in great big chunks like this. Yeah.
You feel your pain.
Yeah, you feel the pain.
Before we pass them around, you want to call.
Okay. Okay, this is called a Sweetwater biface. This is what we call ultra thin, and that cast is not a collapsed cast or anything. That's the real piece is that thin. It's got a width to thickness ratio about 14:1. This is a Dalton related thing. It's a little later than Dalton, so it puts it in early Archaic early Archaic basically in that sort of middle Mississippi area. And just look at the flaking differences on these things. Look at the cross sections. Get a sense of what they're doing in terms of finishing. Of course, these are only finished pieces, and with Clovis, it's not the finished stuff. Here's to me sort of the archetype of a Clovis point, both in size, shape, flaking, all that kind of stuff. This one happens to be a surface find from southeast Utah, but it makes a really good example. This is atypical Clovis flaking, but nonetheless Clovis flaking. This is a piece from the Fen cache. It's an amazing thing, but you can see the overshot flake scars all the way across it. I may as well pass this one around. This is one of the oversized Clovis pieces from the East Wenatchee cache in Washington State. And take a look at that on the side. Just the thing that really distinguishes Clovis is flatness, but not just flatness. This is flat, right? That's really flat. But this is flat and all the way across, whereas this is flat just to the middle. You see what if you look at the flaking differences, the flake scars on this are completely different. This particular one of the very last few flakes that they did over here is an overshot here and an overshot there and another one there. Just three in a row on a flat piece. It's pretty phenomenal flaking. So those are really different finishing technologies, which doesn't necessarily tell you how they got to this. I've got this piece here. Where is it? Which is showing you sort of a sequence of where you take a fairly thick sort of biface like you might find here, and within actually in this case two flake removals, one most of the way across and one overshot, you can see it just flattens it right down. So put those on there, refit those on there and take a look at those, and don't lose that little overshot end because that's worth seeing. And that's what's successful overshot flaking, in other words, intentional, as opposed to, well, I hit it too hard and it went too far, which you can see in a lot of different archaeological contexts. On the other hand, just last week, had a volunteer student in at the lab, and we went through 418 bifaces that came out of the Pierce excavations down here. Okay, so that's the archaic stuff, right? And out of that 418, 8 of them had overshot flake scars on them, 2 of which I'm absolutely convinced are Clovis. So that leaves 6 out of 418, and 2 of those were destroyed the preform. And 3 of those I couldn't tell whether it was intentional. It didn't destroy the preform. But just to give you a sense of that, on the other hand, almost 50% of Clovis bifaces in all stages of manufacture have an overshot flake scar on them. So we're going from less than 1% to almost 50%. That's why we put so much emphasis on overshot flaking. It's a mindset in technology. It's not just a technique. It's a way of thinking about stone and how to change stone into something you want. This, on the other hand, is not exactly Clovis technology, but it's very, very similar. This is in the getting towards the final stages. I've only done this part is next to the last phase. This part is next to the next to last phase, and this is Solutrean style technology. And this would be a example of a finished Solutrean laurel leaf. Okay, this is one I made, but this is out of the French flint and the whole bit. Try not to drop this one. This one I really don't want broken because I have every flake that I made leading up to this in order and all that kind of stuff. I just written an article on this particular piece. So there's lots of different ways of approaching a chunk of rock, right? You want to make a bifacial thing. I had this piece of rock that was just laying here, and I'm not trying to make a biface out of it. What I was trying to do is trying to think of it as sort of how would a Clovis person potentially reduce this thing. And so you can see it's a bold technique. First of all, a lot of platform preparation. Bold technique. I was able to make some big flakes with this off the top of this thing. And for just 3 or 4 flake removals, you got that kind of a thing. Now, I'm not saying this is specifically a Clovis core technique because you couldn't really get to a biface out of this big round chunk. Okay, but I did pick up a couple pieces that haven't been flaked. This is a big round chunk, and then this is a much more typical chert from out here. It's not the best quality stuff. It seems to be a lot of it wasn't used because it's kind of not the best quality, but it's what I could come up with today. So I thought I'd try to make a biface out of this and sort of think Clovis as I'm doing it, okay, instead of just biface. And to me, what I mean by that is as few flakes as I can make to get the biface, basically. Okay, so I've got some real challenges with that, needless to say. I'm guessing that a biface out of this is going to probably maximum size will be about that big. I'm going to lose this whole end here because of this real hollow stuff in here, and this is assuming, of course, that there's no cracks in it. So the first thing I need to do is I need to figure out where the solid parts are, where that biface that I'm talking about where it is. It's hiding in there somewhere. Okay, and where is it? It's about here, looking at the distribution of this mass. And that's what I call, when I do this, here. If you take these bifaces, you take them on edge, they tend to be very flat and very straight edged, and it defines a plane, right? It goes right through there. So a plane is a two-dimensional.